the next one here. The question is, determine whether the object will reach the surface of the sphere. It will reach the surface of the sphere if the potential energy, the work done by the electric force is it has a potential of potential energy. Okay, so you need to distinguish the two concepts here first. That is electric potential and electric potential energy. Okay, electric potential energy is electric potential multiplied with the charge times the charge. Okay.
Yeah.
Electric potential energy is the work done on a certain charge, work done on a certain charge when moving it between 2 points. And electric potential is the work done, but not on certain charge, but on only unit charge. Therefore, you need to multiply that potential with the charge. Okay, the work done on unit charge. Electric potential is the work done on unit charge. Okay, and therefore you need to multiply it with the charge. And so in this case, we need to calculate this work done by the electric force in moving that charge from this point at 2.8 meter to the surface, which is the work done by the electric force is, which is the potential difference between those 2 points, which is 53.9, okay, kilovolt. So that is 53.9, and that is kilo volt. So I need to put times 10 to 3, okay, to convert it to volt. Subtract the potential at the position of 2.8 meter. This position, okay, 2.8 meter, which is the potential there is 7.71. 7.71 times 10 to 3. This is the potential difference, okay? And then we need to multiply with the charge, which is 2.4 times 10 to -8. The charge is here, okay? The potential at this point, 2.7 meter, is lower. 7.71 is lower than the potential on the surface of the sphere.
Yep.
A negative charge will go from lower potential to higher potential. So this charge actually must be negative. If it is positive, it is repelled by this sphere, with electric field. The potential positive. The potential is positive means that the sphere is positively charged. Okay, as we already calculate here, the value of Q is positive. So there are 2 more notes. That is the sphere is positively charged. So the field is outward, okay, outward. And if you push the negative charge away, push positive charge away, the positive charge is always go from high potential to lower potential for that reason. Okay,
Yep.
Positive charge goes from higher potential to lower potential, and negative charge go oppositely. Okay.
Yep.
Negative charge goes from a lower potential to higher potential. So okay, so we need to provide a push, a kinetic energy for this positive charge for it to approach the sphere. It will not naturally go to the sphere by itself because it is positive. It is repelled by the sphere. Okay, and therefore we provide it an energy which is 0.7 millijoule here. Okay, and by calculating this work done, this is the work done by the electric force. And if this work done is greater than the kinetic energy here, it means the energy of the particle is not enough to overcome the push of the electric field. Okay.
Yep.
So it cannot reach the sphere. And so now just calculate this thing, and we will see that this work done by the field is greater than 0.7 millijoule. So the particle will not be able to reach the sphere. So now please use the calculator, calculate this value and write on this page.
Yep.
(1.1 times 10 to -3 joules, which means 1.1 millijoules. Yeah, so please write 1.1 millijoules, and it is greater than 0.7 millijoule, the kinetic energy of the particle, which means the particle does not have enough energy to overcome the push of the electric field, and it will not be able to reach the sphere. Okay. Does not have enough energy to overcome the push, the energy that the that the field meaning it needs at least 1.1 millijoule to reach the surface of the sphere. Okay.
Yeah.
But it only has 0.7 millijoule, the push of the field. Okay. Too close to the bottom of the page, huh? Okay, so that is a kind of difficult question, huh? Understanding the nature meaning it needs at least 1.1 millijoule to reach the sphere.
Yep.